All right, so welcome back. So we're going to finish up on white blood cells. We only have a few more slides. And then we're going to start talking about thrombocytes, so platelets, and how the blood clotting cascade actually occurs. All right, so with that, I'm going to hide myself. All right, white blood cells. So how do they actually know where to go and how do they get there? Well, we talked a little bit about this already. We said that they get to where they need to go via chemotaxis, so they kind of they hone in on chemical cues given either by damaged tissue or by the actual microbes themselves. Let's take a little bit of a closer look. So here what we're seeing is something called the process of emigration. All right. Remember, these white blood cells, as you saw in that image at the beginning of the last lecture, right? White blood cells are just kind of hanging out. Well, they're not hanging out. They're rolling along the walls of the blood vessel, right? They're not in the middle of the lumen. So basically, they're rolling along, and if you remember, the cells of the blood vessels, right? They're called endothelial cells. So they simply roll along the endothelial cells, and what ends up happening, hopefully you can see these terms here. There are selectins, which are on the endothelial cells, and then there's something called integrins on the white blood cell. And in this image, what we're seeing is we're talking about neutrophils. Now, when we have an area of damage, what ends up happening is that those endothelial cells will insert more of these selectins. And basically, the selectins and the integrins work together kind of like the two halves of Velcro, right? So you can imagine that as this white blood cell is rolling along, everything is fine. It reaches an area where there's been damage nearby, and there's all these selectins placed into the endothelial cells. Well, now it's going to get really sticky there, right? And it kind of sticks. And then that's going to be its cue to squeeze between these endothelial cells and then basically sniff down or track down that chemical trail to like where the damage actually is. All right. Stem cell transplants, you may have heard of these. Oftentimes what ends up happening is that they're either going to take stem cells from either the hip bone. They tend to use the hip bone simply because it's fairly superficial and it's a fairly large bone, so they don't have to go digging too far deep under muscles. And again, that it will be a site of erythropoiesis and even white blood cell production. Or they'll do a bone marrow transplant, where basically they are simply, again, they're taking bone marrow from the hip bone, either via syringe or some other method, and then they're going to simply put it into the bloodstream of the donor, or I should say donor, the recipient individual rather. Basically, those stem cells, those bone marrow cells, know where to go. They end up in the red bone marrow, and basically they'll repopulate that red bone marrow. Now, one thing that is kind of tricky about this is basically when they do this, they end up having to, for the recipient, they often have to basically kill off all of the recipient's red bone marrow. Because if, like, for example, if they have like bone marrow cancer or something like that. So basically what they end up doing is they kill them all off, right? Kill off all the bad cells, and then they try to repopulate it by the donor's red blood cells. Or I should say red bone marrow, sorry. Now it usually takes about, I don't know, after like the recipient receives the bone marrow transplant, it takes about 2 to 3 weeks, give or take, for the individual to start producing enough white blood cells to help fight off infections themselves. Now, something to keep in mind, let's see if I can get there's a video you guys can watch, and come on, get my little pen to pop up here. There's something called graft versus host disease. Okay, and this is very serious and it's life-threatening. So what this is, you know how we talked about like a little while ago how your white blood cells know you versus a foreign invader kind of thing? And like with transplanted tissues, sometimes like if you get an organ transplant, your white blood cells will want to attack it because it doesn't see it as you, right? So graft versus host disease is kind of along the same lines, but a little bit different. In this case, you get this bone marrow transplant, right? Remember, they've killed off all your white blood cells, and they've now given you the stem cell. Now, I should mention that, well, again, we'll talk a little bit more about this when we get through the immune system. The way that your white blood cells are developed is that they're, and I'm going to use this in quotes, they're educated to recognize you versus not you, okay? So, and that'll occur in areas like, well, like in your red bone marrow, for example, for red blood cells, and in your thyroid for white blood cells. In your thymus for white blood cells. Now, what ends up happening is that sometimes the bone marrow that is transplanted, right, so it's in the host, it isn't educated properly, so it still thinks it's in the other person. So to it, whenever it produces white blood cells, it thinks everything is an invader. So it actually starts attacking the person who receives the bone marrow transplant. So you can imagine how this is a very life-threatening situation where the host's entire body is under attack by the bone marrow transplant. So they would have to basically go and kill off all those cells all over again and try to get a new donation. So hopefully that makes sense. Okay, let's see if we can get this to advance. My goodness, I don't know why. There you go. You probably have heard of cord blood transplants. You can kind of see this here. Baby's born with the umbilical cord, right? You basically take the cord blood has lots of stem cells in it, and then basically you store them, right? And the nice thing about stem cells from the umbilical cord, well, first of all, you're not hurting a fetus or anything like that. This is just tissue that would have been, I don't want to say thrown away, but not really used anyway. They're easily collected. It can be stored essentially indefinitely. And because these are such precursor cells, they haven't differentiated necessarily into recognizing, self versus not self yet. They're less likely to cause that graft versus host disease. So some stem cell cord blood transplants can be used more easily in, someone who's not related to you, genetically. So anyway, stem cell transplants. All right. Please let me know if you have any questions on these last couple of slides. Again, more than happy to answer them for you. All right. I'm actually going to stop this here, so this will be a really short video, but platelets is going to get a little bit complicated, so I don't necessarily want to start in on something. So we'll just stop it here, and then we'll pick it up in platelets.